All right, let's go ahead and get started. Thanks for joining my session this afternoon right after lunch. Hopefully, my intent obviously is to make sure that you get some information that maybe you can take back to your place and do some cool stuff. So my name is Richard Taylor. I'm from North Carolina, and my day job, I'm a full stack developer. I work for a company called SentryOne. We don't do any Xamarin work, so this is a passion of mine. This is why I come out and do this stuff, to kind of change the pace a little bit. But SentryOne, we build software for the Microsoft data professionals, so performance tuning on databases, things like that, that's what we do. As I said, I live in North Carolina. I organize the local Xamarin group there, and I also organize another developer group that's more of a full stack type of operation there. So that's my website and our blog and Twitter handle, Writing Code. As I said, thanks for joining me. I want to thank the organizers for actually having me. I'm pretty excited about this inaugural summit. It's actually been pretty cool. And so, as I said, I don't do Xamarin as a professional in my day job. I am a professional engineer. But I'm always looking for interesting ways to use Xamarin and solve problems. And I'm a software engineer, as most of you in the room. We look for problems, and we look to solve those problems. And so I was, paying attention to a lot of tech that was coming out. Xamarin, obviously, it's been out for a while, and some of the enhancements. Azure, very hard to keep up with. There's so many things that are happening there. But cognitive services is pretty interesting, particularly when it relates to like mobile apps. And ML.NET, which part of my team at SentryOne, I have a data science team. They report to me, and we work on these interesting problems related to our software. And so I was interested in machine learning and modeling and all that good stuff. And it's like, okay, that's pretty cool tech. How could I kind of put some of this stuff together? And in today's world, information, it's information overload, information coming from everywhere. And so I was kind of tooling around and said, hey, here's a good idea. Maybe I can figure out how to bring these things together and come up with a way to manage information, or at least have the machine or the app help me manage this information so I'm not flooded, right? And so, as I said, there's a ton of information coming at us every single day, every single hour, every single minute. And I found this quote on the internet. If you're trying to get information from the internet, it's like drinking from a fire hose. It's just hard to keep up with it all. And so at the end of the day, end of the week, end of the month, this is what your brain looks like. You've got information coming from everywhere. You're just like, how do I deal with all of this stuff? And so, this talk is about sort of a personal project and how I'm bringing all these technologies together. And so what I came up with was an interesting solution. I wanted to build out a smart reader, okay? And the goal was to initially focus on RSS feeds, so blogs, online magazines, news, things like that. And then eventually expand it to other things. So that's one goal. And then the other goal, I wanted to be cross-platform. We're at Xamarin Developer Summit, so hey, Xamarin's an interesting tool to use for this. So I wanted to do web, mobile, desktop, multiple OSs, so Xamarin was a choice there. And then I wanted to leverage cloud technology where it was beneficial and efficient, okay, and effective. And then tying it all together, I wanted to bring in machine learning and basically try to create some sort of a personalized experience based from the user's point of view, okay? So those are the things I was after for this project. And so I started saying, okay, well, what are the tools, right? Well, obviously, Xamarin is one of them, as Azure Cognitive Services, as I mentioned before, and then also ML.NET for the machine learning. And so before I continue on, let me give you just a brief demo of kind of what the app looks like at the moment. And it's in development, but at least I can show you what's going on with it. So I already have it running, at least a UWP version of it running. And actually, I will show the Android version of it that's running on my device here. And so the concept is that basically you have 3 different areas of this app that you can go into. First off is what you've subscribed to as it relates to RSS feeds. And then there's a search function, and then there's a recommendation area. Okay, and so I can come over here. I've already done some preliminary searches to save time. But here's an example where I went in and I just typed in Houston living. I'm new to the area. I just want to know kind of what's going on from blogging and events and things like that. And so here are the research results. And actually, while I'm doing that, I'm going to go ahead and kick off a search over here. Same search. Okay, and one of the improvements that I still need to work on is how I'm leveraging search. So I'll let that run for a second. So we'll go back over to the UWP app, and here's all the blogs and RSS feeds that actually have come up. Actually, the RSS feeds are not blogs. Most of them are blogs. And so I can actually, let's pick one. I'll pick the Houston Blog Network. So I can click on this and I can subscribe to it. And if I go back over to my subscribe section here, you see now I have a couple of blogs that or RSS feeds that I've actually subscribed to. Now the interesting thing is, and this is really for demo purposes at the moment, is that if I go over to the recommendation tab, you'll see there's a green number next to it. That green number is actually a scoring coming out of the model that I built based upon some relevant information to the blogs that I've subscribed to, okay? And in this example, and when I'm done with the app, I probably won't show the score, but basically the score will be used for sorting, all right? So the higher the number, the more likely that I, as a user, am gonna like that particular RSS feed, okay? And we'll get into how the model works and all that stuff a little later. So at any rate, I can come over here and see all of the other search results and basically how they were ranked, okay? And so the way it works is this. So I'm gonna look at the recommendations first. Let's take a look. So you see 3.1 for that top one. It's not HOU, it's me, it's 1.8, et cetera, right? So since I've subscribed to that other feed, I'm gonna just run this search again, and let's see if the numbers change. So we'll run the search, and while that's searching, I'll just show you over here, same sort of experience. You'll see that there's some scoring there that's going on, and I haven't subscribed to anything on the Android side at the moment. And so, as I said, I need to improve the searching, and make this almost instantaneous, but I will get to that a little later. That wasn't important, at least at this point. And so when the results come back, we should see higher scoring, because the model has changed now. I've subscribed to a feed, and basically now it knows a little bit more about me and what I like. And if I go to the recommendations tab, you'll see the numbers have changed slightly, okay? And over time, it should get better, right? So that's generally the concept, all right? So that being said, let's switch back over to the slides here. And so that was a demo, and it's called Viewpoint Reader, by the way. And I'll show you some links to the GitHub repo and whatnot, and you can take a look at it if you like. So as I said before, the first tool is Xamarin, right? So we're using Xamarin. And typically when I do this talk, this is about the third or fourth time now as the product's evolved, or at least the project's evolved. I'm typically not at the Xamarin event. So I'm spending maybe 10, 12 slides basically building the foundation of why choose Xamarin, for this type of application. I'm not going to do that to you guys today because you guys are using Xamarin. So at least I'm going to assume that you're using Xamarin. Who want to talk Xamarin? There's other talks, or at least get deeper. There are other talks that we can talk offline. So Xamarin's the first tool. So the second tool is Azure. Okay. Now, what exactly am I using with Azure to sort of make this work? So the first area I wanted to go into was Azure App Service, or Azure App Service, specifically web apps, okay? And we'll talk, I have some slides in here, we'll talk a little bit more in detail about what that is and why we're using it. And then Azure Cognitive Services, as I mentioned earlier, specifically the web search and the key phrase extraction. Now, Azure Cognitive Services has a lot to it. But those are the two that that are part of the solution, and that's what we're going to focus on. Okay. All right. So let's talk about Azure App Service for a moment. So just at a very high level, it's a platform as a service offering from Microsoft. And it's used to create a couple things. One of them being web and mobile backends for any platform or device. There are also connectors for integration into other like SaaS services and SaaS products, as well as connections to if you have like on-premises apps or on-premises data that you need to access as well. You can use Azure App Service for that. And then automating business processes. And I'll actually, as an aside, a little further, we'll talk about an example of what you can do with that, and something I did a few years ago. And then also, the cool thing about it, and the cool thing about Azure, is that a lot of the services are managed by Microsoft, right? So you can focus on your app, and you don't need a whole setup in terms of IT infrastructure. And in this case, Azure App Service, it's a fully managed virtual machine that's running in Azure. You don't have to really do anything with it. Now, there are some key features. First of all, auto-scaling. So for me in this project, I'm typically using like the free version of whatever, but as things grow, or if it became popular, if you're a startup, you can start small, but then you can scale, and it's pretty much point and click. There's staging environments, which are pretty cool, and that's actually part of Azure App Service. Continuous deployment. So if you're into having a CI/CD pipeline on the deployment side, this could be the end of that whole process flow, right? You can deploy right into a staging environment, run your tests, and then simply do a swap out your production for staging, and now your code is actually running. And then there are a couple other things like virtual networking, and then isolated dedicated environments. So you can actually benefit from Azure App Service without actually using like shared resources that Azure's managing. You can actually set up something dedicated. It's expensive, but you can set it up if you need to. So why use it? Well, there's a whole list of things. It supports a bunch of languages. For me, .NET, but if you're a Node shop, Java shop, it can run that as part of your backend. As I said before, it supports DevOps optimizations. It supports, it's globally scalable, high availability, it's all built in. And then also the connectors that I mentioned before to popular SaaS platforms and on-premises platforms and platform and data. Security and compliance is part of the platform as well. And then there's templates that if you want to just stand up an environment that already has the software already pre-configured, click a button, a couple minutes, it's up and running, okay? And then of course, one of our favorites is integrated quite heavily into Visual Studio. All right, so when it comes to Azure App Services, there are a couple app types. So the one that I'm using as part of the solution is web apps, and it's used to host websites and web applications. There's also web apps for containers, pretty self-explanatory. Just take that, and it can run in a container. It also has mobile apps, and then that's used to host mobile backends. So now I have this actually marked out or crossed out because at build, basically the guidance now is to use Visual Studio App Center for what this used to do. And what this did for you, things like authentication, notifications, data storage for like your mobile apps, that's what actually mobile apps brought to the table for you. But now Visual Studio App Center is the way you should go, all right? And those same services are provided. And then there's API apps. That's basically used to host RESTful APIs. I have a strike through this as well because last month, actually Microsoft removed this and basically used web apps for this, which essentially is the same thing behind the scenes, and it made sense. And then there's logic apps, and basically this is used for automating business processes. And so just a quick aside, so I played around with this several years back to try to figure out, what exactly I could do with it, and it's actually pretty cool. I had basically a web sign-up page, and it wrote, when a user signed up for this particular app, it wrote the data out to a SQL Server database. And so what I wanted to do was, okay, well, once somebody signed up, let's send them a welcome email, and also let's notify someone, in the company and say, hey, someone signed up, right? Well, I didn't want to actually go back and modify the application itself to actually do the emailing and all that sort of stuff. So actually what I was able to do was use Logic Apps to actually monitor a table in a database. And once a new record hit, the Logic app would actually pick that up, integrate with SendGrid on Azure, and actually send the user an email, a welcome email, and then also use Twilio to actually send a text message to someone on site or at the company. And I did all that without writing a line of code, which is pretty cool. So yeah, so those are the app types, and then and that's Azure App Services. Okay, so now we talk about Azure Cognitive Services. So basically, this was designed to help developers build intelligent applications without having to know a bunch of AI, machine learning, and that sort of stuff. And I'll be first to say that I'm not a data scientist. I'm just playing around with these cool tools. So cognitive services, to me, that brings a lot of value to the table. I can get things done without learning or at least knowing all of the theoretical background and studies behind all that sort of stuff. So it's basically delivered via RESTful API and SDK. So that being said, you have all these options, right? You can use the SDKs if they're available for the platform you're writing or at least developing on, or just about everything has access to some sort of like web client or communication, so you can use the REST service as well. Okay, so that makes it pretty basically universal. It supports multiple conversational languages, which is actually pretty cool. When you get into the language aspects and text processing and things like that, it doesn't have to be English. It could be other languages as well. And then it generally covers these main areas. So we have vision, which there's tons and tons of examples of using vision. Also speech, language. There's also search, which we're leveraging actually in this particular solution. And then there's decision, so anomaly detection, content moderation, and then there's this new thing that just recently came out, personalizer, which is actually very similar to what we're doing here in this app, but it's in preview, and I'm probably going to take a look at it in a few weeks. But basically, that's designed to create sort of a unique experience for an individual user, which is actually kind of what we're after. So that came out actually before I actually started working on this. So at any rate, that's Azure Cognitive Services, and those are the tools, at least from an Azure perspective, that we're using as part of this solution. All right, and lastly, the third tool, ML.NET. So what is it? It's a machine learning framework, okay? It is cross-platform to a point, and I'll explain that in a second. It doesn't support the ARM processor architecture, but it is on a roadmap. So when I started this project, the concept was to actually do all of the model building, training, and predictions actually on the device, okay? And early on, probably, I guess maybe 2.5 months or so ago, when I started playing around with this, I could actually get it to work. But it wasn't supported, and then officially a blog post came out when ML 1.0 came out that we're not supporting this, but it's on the roadmap. And so I tried to stick with it for a while, and then things started breaking, and I just gave up. And so I changed the architecture of the solution, and we'll talk about that in a minute. I have a diagram that actually shows how all the pieces work. So if you're thinking about using ML.NET as part of like your mobile solutions, for the time being, you're going to have to actually do what I'm doing here and host it somewhere. And in this case, it's actually hosted in Azure, and we'll talk about that in a little while. All right, so ML.NET is designed to allow developers to build a custom learning model, okay? So as opposed to cognitive services, where a lot of that stuff is already built for you, you're just making like REST calls or using the SDK, ML.NET allows you to actually manage the entire process from your code. So importing the available data, that's a step that's typically done in machine learning when you're building your model, and then transforming that data for training. And typically, that's basically making sure that the information as it's coming in, the machine can distinguish between values and what's called features, and we'll talk about that in a second. So then creating the model, training the model, test the model, and then using the model. That's all part of this whole framework. And I'll actually in code, we'll take a look, and I'll show you the various steps. And then lastly, ML.NET is pretty extensible in terms of models. It's built so that you can actually bring models in, export them out, and use them in other frameworks. And so that's one of the tenets of the design, or at least design goals. Okay. Currently, it's version 1.2. It was 1.0 at build, so there's been a couple of updates since then. So, and actually, the framework itself has been around for a while, but it was started in terms of development in public maybe a little over a year ago. And if you had kind of got in then and started watching it, there's been a year of development basically in the open, which is pretty cool, and it is open source. All right, so how does all of this kind of come together? And I'll try to create a visual for you in terms of how it works. So first off, here's sort of a system architecture view of what's going on, okay? So on the left-hand side, the Viewpoint Reader app, the app itself is actually running on your devices, okay? And locally, there's a SQLite database where all the subscription information is actually stored, okay? And so, if you're offline, but you still want to look at your subscriptions and things like that, all of that information is obviously available. On the right-hand side, this is where all the back-end services are, okay? First off, we talk about Azure App Services, which is at the top. There's some secondary subscription storage and information out in Azure. Parts of it, the actual subscription information itself is actually stored in table storage. And then as far as model maintenance and prediction, we're using ML.NET in that service, and the model itself is actually stored in blob storage. So when we need to access it, we're going to blob storage to get it, do a prediction, and provide a response. And so all of that is actually behind a web API, okay? And then down at the bottom on the right, this is where Azure Cognitive Services comes into play. And we're using the two key components I mentioned earlier. So we have web search, and then we also are using the language component, which are several, sub-pieces. Specifically, we're using key phrase extraction, okay? And I'll explain how the application works, but that's pretty much how the different major pieces and parts kind of come together, okay? All right, so the application and how it works. And so the app's running in the center, and as I said before, there's local storage of all the subscribed feeds. And so when we do a search, what the app does is it actually takes that text phrase and actually sends it off to Azure Cognitive Services, and we're using the web search component, okay? It's backed by Bing, and basically it presents some results, and then we process those results. And what we're looking for when we're processing those results is sites that actually have RSS feeds associated with them, all right? And once we find an RSS feed, then we actually process that a little bit more. We look for the actual items or actual articles that have been published, and we actually gather that information. All right. Once that information is gathered, then the next step is we actually take a look at the description of the feed itself, and we use Azure Cognitive Services to actually extract key phrases. And the key phrases is sort of the key to the machine learning. So once we pull out those key phrases, that's all stored into the local database as a subscribed feed, okay? Now, the next step is, well, once you have subscribed to the feed, then what the app does is actually pushes the subscription off to Azure and into table storage. And actually, the app doesn't know anything about table storage. There's a custom API that it posts to, and then that takes it further into the Azure services. There's a specific reason we're doing that, because we need access to the key phrases, because those drive basically the creation, the maintenance, and the learning of the model, okay? Also, in Azure is obviously we build and we update the recommendation model from the subscribed feeds. And that's then fed back when we switch over to the recommended tab. You see the force ranked feeds based upon their scoring. Okay, so that's how kind of all of it sort of comes together. Any questions on any of that? Okay. All right, so current state. So obviously there's more work to be done. I want to improve the search. Obviously I haven't gotten installing yet, but it's usable. And I'll switch back over and we'll take a deeper look into some of the other features. And then also I'm intrigued about getting ML.NET and model training and whatnot on the device. I'm not sure if that's the right choice yet, because obviously processing and power and things like that, depending on the device, may not be there to actually do that. So maybe it's optional depending on the device. All right, so that being said, let's go back over to the app real quick. And so let's do Houston Living. And this is another piece too. I've got to figure out on the Azure side, there's a little delay because sometimes the services spin down and it takes time to spin up, so there's sometimes a delay there. But I've got some creative ways actually, I think, to deal with that. So we go back over to subscribed, and I click on this, and then you get all of the published articles. And they're sorted by date and time. And you get a description, and we'll just take a look at this one real quick. I can click on it, and basically it jumps me out to the actual website, and I can actually read the article once it comes down. In addition to current state, there's a few other things. Unsubscribing, I just need to turn that on. But marking things red as well, so they don't show up in that list, that needs to be done as well. But you can see it's good structure in terms of how the concept's going to work. And it's basically just bringing home some of those features, using Xamarin Essentials to actually do that. But basically, that's how that works. Okay. So that being said, let's take a look at the code. All right, I'm gonna actually I can leave it running. That's fine. All right, so let's see. Magnify. Let's bring it over just a little bit. All right, so this is the solution. It's a typical solution. In the targets folder, those are the platform-specific outputs, or at least projects for the outputs for each one of the platforms. Currently, all of them do work. I've shown you the UWP and the Android one. There is an iOS one as well, and it works. I'm using Mac and Cloud to do, at least to be able to do the compile and run the simulator. But I want to point out just a few things, and then we'll take a look at the actual code itself. So from a project standpoint, you see down here Viewpoint Reader Web API. That's the actual backend that the app is actually talking to. And then you'll see a few other things that I wanted to point out. So you have the Viewpoint Reader, which is basically sort of at the core. This is where all of the my views and view models and such related to the app itself. And then all of the rest of the application is broken out into the various parts. So you have Cognitive Services, all the codes there. Basically, it follows generally clean architecture. So most of the business models are in the core project. The data access is in the .data project. The model builder project actually is a .NET standard project that I originally had linked up to the application itself. But the cool thing, because it was in .NET Standard, I was able to build the API and just reference that, and all the code still basically worked. The only other work I needed to do was switch out the persistence pieces. So a common, all the code's written to a common interface, and so basically swapping it out, most of the consumers of that code just continue to run, even though it went from, or it got extended from local storage to table storage, et cetera. So let's take a look at the code real quick. Here is the controller, which is only one. It's a very simple web API. And there's a couple of functions that we have, or at least methods that we have on it. And the first one is get, which basically brings back a list of the feeds that you have subscribed to. You'll see here, it's pretty simple. Using a simple repository pattern, get the feed subscriptions, and it feeds it back as a data set, and the app renders. Same thing for post. Once you subscribe to a feed, what it does is obviously we write it locally, and then we actually make the post to the API, which then actually stores that information in table storage. Again, repository pattern, same interface, it just writes it out. And when we need to build the model, or at least update the model, then we actually post to this endpoint here, where we're using a model builder library, and basically it has a method on it called build model, and it does all of the work in terms of retraining the model and actually making it available. And we're going to switch over to that code in just a second. And lastly, when we're scoring a feed. So once the search results come back, we take that collection and we actually send it off to this API. Each one gets scored with a number, comes back, and we sort on the client, and that's where we're actually using the model to do the scoring. So let's dig into that just a little bit. ML.NET is basically a set of NuGet packages, and you see here ML.NET or Microsoft.ML 1.2, and then there's some functionality I'm using in this ML.Recommender, which basically does the scoring for us and allows us to send a value back. So taking a look at the code, the two things that are exposed here is build a model. Let's talk about that for a second. All right, so remember earlier I kind of walked you through sort of the process, right? You create a model. First you have to find your data or import your data. Then you transform it into something the machine can use to provide some sort of a score. You train it, and then you can start using it at that point, right? Oh, and I skipped a step, test, but there's not a lot of testing going on here yet because it's fairly simple. And actually, if you're a data scientist, testing is pretty important, obviously, for the accuracy of the recommendations. And so you'll see here, I'm actually calling the repository here. Now this is actually that same pattern, but the data is actually coming out of table storage in Azure. So get feed subscriptions. And then ML.NET has this cool feature here called load from enumerable. And you give it a data type. And so it can take that source data and actually look for those objects and actually create a data set that you can use to train, which is pretty simple. I mean, actually pretty cool, but it's simple from a developer standpoint. Now there are other options as well. You can do you can custom process CSVs and pretty much any data source that you or data format. You can do your own custom processing if you like. But once you have the training data available, then there's a transformation step. Now, one of the things that, and I think it's a primary function of the sort of data science role, is to uncover what's called features, all right? And the features are used to basically model out the data points that are relevant to the problem that you're trying to solve using data science and machine learning. And so data scientists, I know the ones on my team, they spend a lot of time trying to, testing. They'll try different sets of features. They'll include things and exclude things and see how the model performs. And so in this particular case, it's very simple. I just want to use the key phrases. So there's been a lot of data science going into Azure Cognitive Services in terms of pulling out important key phrases out of a set of text. I'm just going to leverage that and not create another layer. It's like, okay, well, that work's already been done. Give me the key phrases. I'm just going to create a simple model based upon that. And the more common, or I guess basically the phrases are being used to determine what I like as a user, and so that it can do future predictions. And so you see here, basically what we're doing is I'm pulling out key phrases from the actual type, and it's going into, or this is being transformed, and I'm using binary classification to actually make sense of basically those features. And then the next step is we train the model. So once we've done the transformation, now we're training the model, and then this last step here is we're actually saving the model. So I don't have any testing going on at this point. Now we are using blob storage, as I said before. So I'm actually saving the model in a memory stream, and then I'm actually writing that memory stream out to blob storage for retrieval at a later date. All right, so that kind of shows you how ML.NET is kind of following that process, or at least my code leveraging ML.NET is following that process of create, train. In this case, we're not testing, and then make available for use. In that case, that's the storage. All right, so then now the other method that's public is scoring. And so here's how this works. So we do it, as I said before, the search results come back. We send the feeds off to the API. They come in and we process them. And so what we're going to do is use the key phrases. So it has the same, basically the same type, right? And so there's basically a field there where we examine the key phrases, which is basically a collection of or a list of strings. And then we in line 137, we create a prediction engine, which is basically loading the model, okay? And then we call predict, which basically provides a score. And then we return that score, which then gets matched up with that particular feed, and then it actually comes back to the app, and that's the numbers that you see on the back end, or I'm sorry, on the front end with the user. And that's pretty much it in terms of the machine learning and ML.NET. Now, cognitive services, we'll talk about that for just a second. So cognitive services, I am leveraging I'm actually leveraging the SDK, right? And so that being said, essentially there's some setup. You have to create the service in Azure. Similar process, you get some API keys, you provide those to the call, and kind of away you go. You can use the service. So right here, search async, which is the public method here, we do an asynchronous call to this private method here that just does the search. And what you see here is where is it? Right here. So Azure Web Search API client, which was created above using the API key. There's search async, and then which is the method you call on in the from in the SDK, and you provide all of these parameters, of which I'm providing query, and basically they're not required, so most of it's all nulled out. And it actually does a simple web search and provides you a collection of results, the collection of web pages basically. And down here I'm extracting the relevant data that's important from that standpoint, and then I'm feeding that as a response, okay? That's all there is to using Azure Cognitive Services and web search. And then equally simple is the key phrase extraction. So we're creating a client. I have a hard-coded endpoint. Obviously, that will come from some sort of configuration if it was production. And we have one simple method, public method, extract key phrases. And it, as I said before, you can do multiple languages if necessary, or other languages if necessary. And then you call key phrase async. It'll take that string that you gave it. It will come back with key phrase results, and then I actually create a collection for that particular feed, attach it, and make it available. So that's all there is to Azure Cognitive Services text analysis. So now let's jump into the actual app itself and try to make a lot of sense out of this. So on the search screen, and we'll jump straight to the view model. All right, so down, let's see, where is it? Search. So we do a couple of things. First, we clear our results. We give some status, and I check for network access. And then I call this, actually is my class here, Viewpoint Reader, our RSS reader, search for it feeds async. So that actually ties into all of the stuff we talked about from web searching and actually gets the results. The results come back, and then I spin off a couple processes in parallel to actually extract feeds if they're there. So there's actually a lot of work going on in that. But once it all comes back, then if there are feeds found, we basically display them. Okay. All right. And so if we go up here, where we're doing the save. All right. So I have my list. I subscribe to one, we do the save, and we do a couple things. There's some conversions from business objects to data objects and whatnot. We do all of that sort of stuff, and then we write out the subscription to the repository, which actually stores it locally. And then lastly, we save the feed out via the API, web API, to the table storage in Azure, so that's available for modeling. All right, and let's see, I have 5 more minutes. Score and save. So what happens here is this is called when the results come back, and what we want to do here is we want to get a score. So on the recommended page, you will actually can kind of force rank them by result, and so we call score feed, which, if we take a look at this code real quick, will take us over to some code where we actually make a request and we post actually the feed to the API, and that's when it runs through ML.NET, which we saw before, where we score based upon the key phrases and actually returns a score, which then is made available to the recommendation screen. All right, so to wrap things up, if you want to play along or play around with the code or follow along, that's the repo at the top where all the code is, Viewpoint Reader, on my GitHub. Again, when I give this talk, it's typically not hardcore Xamarin folks, so I list out all the Xamarin docs. If you want more information about Azure App Service, and actually I need to remove the mobile apps and redirect to Visual Studio App Center. But Azure Cognitive Services and ML.NET, that's all there. All right, so that's what I had for you for this session. Any questions on any of that stuff? Yes, sir. Mm-hmm. Mm-hmm. I'm sorry? How do you guarantee that your model does not overfit? Oh, how I'm going to guarantee I'm not dealing with like an overfit situation? I don't know yet. I haven't really thought about it. This is sort of the beginning of this project. I'm not a data scientist, so my next step actually is to kind of talk to the folks on my team to say, hey, take a look at this thing I'm playing around with and talk about some of those scenarios. So it doesn't address any of that. It is a problem and something I need to deal with. Any other questions on any of this? Yes, sir.
Do you have an idea how can you leverage this to multi-user? Because this is your...
Oh yeah, absolutely. So my original plan was to actually have the model on the device, which that would work, right? So in this scenario, in one of the future phases, if I get to that before it's actually supported on the devices, then obviously I would have to have some kind of unique identifier. Each person would have their own model and segment that in all of the storage that we have out there, and of course use that key as a part of the calls or interfaces or interface to the API et cetera. So yeah, that's how I would deal with it. Maybe even add some kind of authentication. Maybe they log in and then can use it, something like that. But yeah, it's doable. Any other questions on any of this? All right. Well, I will. I'll be around if you have any questions or want to, bounce some ideas or play around with it. But I appreciate you spending 45 minutes with me while I share that with you. Thanks so much. Enjoy the rest of the conference.